All right, lesson 120. I think the biggest takeaway from here is their talk of electric dryer circuits and receptacles. Other than that, it's a fairly light chapter, but I do want to speak a little bit on electric dryer circuits, and specifically the difference between our 4-wire circuit or a 4-wire receptacle and a 3-wire receptacle. These are both in use today. All new installs we'll learn about here have to be the 4-wire. Some older existing installations are actually still the 3-wire type. So I'll kind of talk about why that is, why that's allowed, and what sort of rules and concerns we need to watch out for. So, they're pretty similar, but they've got a couple key differences. So here we have the 4-wire, here we have the 3-wire type. Both are 120/240 volts, so we, at some configuration in this receptacle, depending how we read, can get 240 or 120. I'll explain that here in a moment. Both are single phase, basically meaning they're not 3-phase, okay, it's residential. Both are rated for 30 amps, so your typical dryer circuit is a 30 amp circuit. Now the 4-wire is rated NEMA 14-30, whereas the 3-wire is technically known as a NEMA 10-30. So on our 4-wire we have 2 hots, we have 1 neutral, and we have 1 ground, whereas on the 3-wire we have 2 hots, and then we have sort of this neutral ground combination, which I'll talk about in a moment. So on your 4-wire you got your 2 hots here, you got your neutral is this little L shape at the bottom, and our ground is sort of this U-shaped one at the top. So if I'm to take a voltage reading between the 2 hots, I'll get 240. If I go from one hot to neutral, or the other hot to neutral, I get 120. Same if I go from hot to ground or hot to ground. Looking at the 3-wire, similar, but with the natural difference, we're missing this dedicated ground up here. So we have 2 hots. Now we have this sort of ground neutral combination. So that's why we get away with 3 wires, right? So, but let's just talk on why do we have this 3-wire? Why is it okay? And a little bit of the history of it too. So it was actually allowed back in 1942, and all the way up to 1996 they allowed this as a new install. But as of 96, any new installs have to be 4-wire type. A little bit of history I find interesting. It's actually an effort to save copper for World War II. So they made an exception, said, hey, cut back on that extra neutral wire. We need to save copper for the war effort. You see, they forgot about it till 1996, though, right? But existing installs can remain as 3-wire. If there's already a 3-wire in there, we don't necessarily have to go tear it out. But any new installs must be 4-wire. And that's why you're going to see, if you ever notice, if you bought a dryer, somebody bought a dryer, you can actually change the cord out from a 3-wire to a 4-wire. And this is why, because both exist and both are technically allowed and legal, right? So just look at some connections here, because naturally we have an extra wire. How can 4-wire and 3-wire connect to the same equipment? Well, the textbook has a really nice diagram here. So on your 4-wire, I mean, there's no surprise here, right? Your white wire is your neutral, your black and your red are your hots, and then your bare wire is your ground wire. Okay, so your bare wire is grounded to the box. But where it gets a little odd here, I think, is in the 3-wire setup. So we have 2 hots, and then we have what I'm calling this neutral ground combination. Now in all reality, this is going to be a 2-wire, so it'll be a black, a white, and a bare conductor. So you'll have your black as a hot. You're actually going to then use your white as the other hot. And this wire here, the one that they have white, is probably going to be a bare wire. So it's actually a ground if you really think about it that way. So it does look a little odd to have that white wire wrapped around the ground screw. That's probably not going to be the case. This is probably going to be a bare wire in all cases. Okay, so hopefully, and maybe that's ringing some alarm bells in your head that, hey, maybe that's not right. And like I said, technically it kind of is, but I want to talk about some of those dangers here in a little bit of why we've gotten away from the 3-wire. But as far as your connections go, and they're all going to be a little different, but this represents the actual connection at a dryer. So if you get in that wiring compartment, in this one for the 4-wire, again, no surprise. We have a black hot, we have a red hot, we have a white neutral, and a green ground, right? We have no issue. We can land all our wires like that. The difference is, if you really want to look at them, notice there's nothing connecting that neutral and ground, and why should there be? But on this 3-wire, there is a bonding jumper. So if you're going to install a 3-wire cord, all dryers are going to come with some means to jump between your neutral and your ground. Okay, if we have a 4-wire setup, pull that jumper out of there. We don't want that. We want to keep our ground and neutral separate if we can. Okay, so the dangers of 3-wire, and I think they're real dangers, but keep in mind as we talk about this, there's tons of installs that are like this and are going to be used for a long time just like this. But this first illustration shows a normal 4-wire setup. What happens? What's the current flow look like? And this is a diagram of all the internals of the dryer. It doesn't matter too much exactly what everything does, but you can kind of see here we have 240 heating elements, right? So we have the black leg comes in and the red leg comes in. But then we also have some 120 items. A motor, a light, in this case, there's probably a timer of some kind. So the dryer has some 120 loads and some 240 volt heating elements all combined, right? So again, normal 4-wire setup in this case, we see that we have current traveling on this neutral wire, okay? And that's no problem, that's what we want it to do. But let's sort of flip this and look at what if this is now a 3-wire setup. So essentially we've lost our neutral wire here. We no longer have that, right? Because we're only doing a 3-wire. So we got a black, a red, and a green. Or 2 hots, and then sort of your combination ground neutral. So first thing we got to know is we've got to put that jumper wire between the neutral and the ground, okay? And we'll sort of see why in a moment here, so as we let the electrons go. So they're all following the same path till they get to here. And now they've got to jump down this jumper from neutral to ground, and they actually run through the ground wire. So in this case, we actually intentionally put current on the ground wire. And with this being one of very few exceptions, that can be a really bad thing. So again, in my mind, if you're in this panel, what do you know about a ground wire? We can pull that off the ground bar if we're doing some work. Shouldn't be a big deal. But in this case, if that dryer's running, we now have actual current on that ground wire. So naturally, you can see why this can be a pretty real hazard and why we're no longer allowed to wire things up this way. Back in the 50s, they didn't quite have the understanding like we do, or the eye for safety. But as you can see here, we have current flowing on a ground wire in this case, and it'll probably be a bare ground wire as well. So if this connection comes apart at any point, it can become a real dangerous thing for anybody to get tied up in. And it's kind of a similar situation. People ask, why can we only bond a ground and neutral at the main service? And this kind of explains why. If we are to bond a neutral and ground anywhere else, we're encouraging current on the ground. So that's kind of an aside. But anyway, long story short, all new installs have to be 4-wire. Existing 3-wire installs can remain. We just would need to have the appropriate cord, a 3-wire or a 4-wire on that dryer. If we're going 3-wire, don't forget about your ground to neutral jumper.